When I was about 8 years old, shoveling snow on a freezing day in Colorado, I had a strange thought: what if I could teleport to the surface of the sun for just a nanosecond and then instantly come back? I figured it would warm me up but not hurt me. So what would actually happen? The surface of the sun is about 5,800 Kelvin, extremely hot, but a nanosecond is unbelievably short, 1/1000th of a second. So short that light only travels about a foot in that time. During that instant, sunlight would flood into your eyes, but the total energy would be tiny, about a microjoule, roughly the same amount of light you get from briefly opening your eyes in front of a bright screen and snapping them shut again. Your retinal cells wouldn't even respond right away, since they take milliseconds to process light, so by the time your brain noticed anything, you would already be back on Earth. From your point of view, you'd just see a brief flash that slowly fades. Your skin wouldn't heat up much either. The energy absorbed would be thousands of times less than holding your finger in a lighter flame for 1 second, so you probably wouldn't even feel warm. So, a nanosecond on the sun's surface would be surprisingly harmless. But if you messed up the coordinates and teleported inside the sun, that's a completely different story. The sun's core is millions of degrees hot, and even for a nanosecond you'd absorb a huge amount of energy, enough to cause severe damage instantly. On top of that, the radiation inside the sun is mostly X-rays, which would penetrate deep into your body, heating your organs and damaging your DNA before you even felt anything, so definitely don't teleport into the sun's interior. And about Icarus, his wings didn't melt just because the sun is hot, but because heat damage depends on both temperature and time spent absorbing energy. In theory, if you could teleport in tiny bursts, you could visit almost anywhere safely, but some places, like the inside of a star, are still a very bad idea. Now, let's push this idea further, because the sun is just one example. Temperature alone doesn't determine whether something is dangerous. What really matters is how much energy you absorb and how long you're exposed to it. That's why touching a hot pan for a fraction of a second might not hurt you, but holding it for a few seconds definitely will. If you could teleport in extremely short bursts, you could survive environments that would normally be instantly deadly. You could stand next to a volcano, dive into the ocean's deepest trenches, or even visit planets with crushing pressure, as long as your visit was shorter than the time it takes for heat pressure, or radiation to transfer enough energy to harm you. But there's a catch. Many dangerous environments aren't just hot or high pressure, they're filled with particles and radiation that move incredibly fast. Even in a tiny fraction of a second, those particles can punch through your body, break apart atoms, and damage your cells in ways that don't require heat or time to build up. That's why places like the inside of stars, nuclear reactors, or near black holes would still be extremely dangerous, even for a teleporting nanosecond traveler. So the dream of instantly warming up on the sun is kind of hilarious in hindsight. You'd barely notice anything at all. But it also shows something important about physics. Nature doesn't care about how cool something sounds, only about energy, time, and how fast that energy moves. And there's another weird side effect of teleporting for a nanosecond. Your brain would always be late to the party. Your nervous system works on millisecond timescales, which is millions of times slower than a nanosecond. So by the time your brain realized something intense just happened, it would already be over. That means you could technically experience extreme environments without consciously feeling them in real time. You'd just get delayed signals like flashes of light or faint sensations long after you were already safe. This also means that trying to use nanosecond teleportation as a heater would fail miserably. You wouldn't warm up because heat transfer needs time, and a nanosecond just isn't long enough to dump meaningful energy into your body. It's like dipping your hand into boiling water for an unimaginably tiny instant. It's technically touching something incredibly hot, but practically meaningless. So the childhood fantasy of instantly warming up by visiting the sun is actually backwards. To warm up, you'd need to stay much longer, and that's exactly what you don't want to do. In the end, this thought experiment shows how counterintuitive physics can be. Extreme temperatures don't matter if the time is too short, and tiny time intervals can make even the most dangerous places seem harmless. Right up until you stay there just a little too long. So what's the takeaway from all of this? Our intuition about heat and danger is built around everyday timescales. Seconds, minutes, hours, not billionths of a second. When you shrink time down to nanoseconds, the universe starts behaving in very unintuitive ways. The sun can feel harmless, a lightning bolt to be survivable, and even the surface of a neutron star might not have time to crush you, at least not immediately. But physics always catches up. The moment you extend that time even a little, energy starts piling up, atoms start breaking apart, and your body stops being a body in any recognizable sense. Teleporting in tiny bursts sounds like a superpower, but it mostly highlights how slow and squishy humans are compared to the extreme speeds, energies of the cosmos. The sun isn't dangerous because it's hot. It's dangerous because it's hot for a long time. And in the end, that's the real lesson. In physics, time is just as important as temperature, and sometimes a billionth of a second is the difference between a cool thought experiment and instant cosmic barbecue.